Hello students, welcome to the lecture of hydrocarbons. In the previous lecture, we have completed alkenes and we had started the discussion of alkynes. So, now we will discuss in details about the structure, bonding and different other properties of alkynes. So, let us start. So, alkynes, as we had discussed, alkynes are unsaturated hydrocarbons with at least one carbon-carbon triple bond. Okay. So, in an alkene there should be at least one triple bond between two carbons. Now, since carbon has a valency of 4 and the 3 bonds are completed here, so these carbons will have only one bond left. So, naturally the number of hydrogen in alkyne is less than the alkanes and alkenes. Okay. So, of course, ethyne is the smallest alkyne because similar to alkenes, one carbon alkene or alkyne is not possible, that is why ethyne is the smallest alkyne. And we had seen that while naming alkanes, we put ANE at the end, that is N. For alkenes, we put ENE, that is in, and for alkynes, we will put YNE or ine at the end. So, like we had seen, for the alkanes, we had the general formula as CnH2n plus 2. For alkenes, we had the general formula CnH2n. For alkynes, we have the general formula as this CnH2n minus 2. So, using these general formulas, we can draw a table. So, number of carbons, formula, name and structure. Okay. So, when the number of carbon is 2, we will have the alkyne as C2H 2n minus 2, right. So, 2 into 2 means 4, 4 minus 2 is 2. So, we will have C2H2 and the name is ethyne, and ethyne is like this. Okay. So, when the number of carbon is 3, we have C3H, 3 into 2 is 6 minus 2, that is 4, C3H4, that is propyne. Okay. So, it is written as on one carbon there will be a hydrogen and here one more carbon. So, this is propyne. If we have C equal to 4, then we will have C4H6, that is butane. So, butane is this. Butane will also have isomers of course, but we will study about them later. So, if carbon is 5, then we have C5H8, this is pentyne. Okay. So, as we increase the number of carbons, we will get higher alkynes with these formula. Okay. So, now let us talk about the structure of alkyne. Okay. So, in alkyne we have C triple bond C. So, in this triple bond we have 1 sigma and 2 pi bonds. Okay. So, among the 3 bonds between the 2 carbons we will have 1 sigma and 2 pi, and of course both of these carbons will have one more sigma bond with hydrogen or carbon. So, alkyne carbons, that is triple bonded carbons, are sp hybridized. Triple bonded carbons are sp hybridized. Okay. So, sp hybridized will mean this is 2s, this is the electronic configuration of carbon. So, if each orbital gets one unpaired electron, then sp means 2 orbitals, there will be 2 sp hybrid orbitals. Okay. And we have 2 p orbitals left, which is unhybridized. So, sp hybridization will have 2 sp orbitals which will form 2 sigma bonds, okay, and 2 unhybridized p orbitals will form 2 pi bonds. Okay. So, how will be the 2 sigma bonds? Let us say this is one carbon. So, each carbon will have 2 sp orbitals. So, one sp orbital forms sigma bond with another carbon. This is one sigma, right? Now, another sigma bond will be formed with hydrogen for each carbon. Okay. This sigma bond is between sp of one carbon and sp of the other carbon. This sigma bond is between sp of the carbon and 1s of hydrogen. Okay. Now, these carbons will have 2 unhybridized p orbitals, right? So, if we draw like this is one pair of p orbitals and this will be another pair of p orbitals. Okay. So, these p orbitals will form pi bonds. So, let us show how pi bonds will be formed. These are 2 carbons. Okay. Here is one p orbital. These p orbitals will actually overlap, right? So, we can draw it like this. Like this, pi bonds will be formed. So, one pi bond will be between these 2 p orbitals, pi, and the second pi bond will be between these 2 p orbitals. Okay. So, these are parallel orbitals. So, pi bond is formed between parallel p orbitals, that is px of one with px of the other, or py of one carbon to the py of another, like that. Okay. So, we have, this is also pi, 1 sigma and 2 pi bonds. These comprise the triple bond. Okay. So, now these pi orbitals have symmetrical electron cloud. Symmetrical electron cloud. Now, let us see a comparison between the bond strength, bond length and bond angles of alkanes, alkenes and alkynes. So, let us talk about bond strength. So, C single bond C has a bond strength of 348 kilojoule per mole. C double bond C will have a bond strength of 681 kilojoule per mole, and C triple bond C will have a bond strength of 823 kilojoule per mole. So, obviously, triple bond is stronger than double and single bonds. Okay. Now, bond length. Single bond has a bond length of 154 picometer. Double bond has a bond length of 133 picometer, and triple bond has a bond length of 120 picometer. We know that bond length is inversely proportional to bond strength. So, when the bond strength will increase, the bond length will decrease. So, triple bond has the highest bond strength, but lowest bond length. Similarly, single bond has the lowest bond strength and highest bond length. Now, bond angle. Okay. So, for alkanes, we will talk about the HCC bond angle. Okay. So, HCC means this one hydrogen, one carbon, the next carbon. We will compare this bond angle. Okay. This bond angle we will compare. So, for alkanes, that is for sp3, this was 109.5 degree. Okay. For sp2 hybridized, that is carbon-carbon double bond, the bond angle was around 120 degree. And for sp hybridized, that is the alkynes, C triple bond C, the bond angle will be 180 degree. Due to this angle 180 degree, we will never write the alkanes as this. Okay? This is wrong. The alkanes will have to be written in straight line. Okay? This is the right form, since the bond angle is 180 degree. And in this case, we had seen that bonds are formed between two parallel p orbital of each carbon, but these two unhybridized p orbitals that were left, right, that is this one and this one, these p orbitals are perpendicular to each other. That is, these two p orbitals lie in different planes. Okay. So, this was the structure of the triple bond in alkynes. Now, we will discuss about structural isomers of alkynes. structural isomers of alkynes. Okay. So, ethyne and propyne have no structural isomers. Okay. Now, if we talk about butane, for butane we can write like this. This is called but1-ine. We can also write like this. This is called but2-ine. Okay. So, in this molecule the triple bond was between carbon 1 and carbon 2, but in this molecule the triple bond is between carbon 2 and carbon 3. So, these are positional isomers. Now, if we talk about pentyne, so the one is this, this triple bond is between carbon 1 and carbon 2. This one we will call pent1-ine. The second one will be this, that is the triple bond is between carbon 2 and carbon 3. This is called pent2-ine. Okay. And there is one third isomer as well. This one. So, this one has a 4 carbon chain and we will call this as 3-methyl but1-ine. Okay. So, this pent1-ine, that is structure 1 and structure 2, they are positional isomers. Okay. But this 1, 2 with 3 has a 4 carbon chain and 1 and 2 have 5 carbon chains. So, this one can be known as a chain isomer of the other two. Okay. So, we have discussed about the structure of bonds and isomers of alkynes. In the next lecture, we will study more about the structural isomers and the preparation of alkynes. Thank you.